Hey everyone, welcome back to Fabric Espresso series and the episode about Spark data engineering patterns, shortcuts, and external tables. My name is Estera, and today I have a really special guest, Daniel. Daniel, thank you for being here. Could you take a moment and introduce yourself to our listeners?
Thank you for having me. So my name is Daniel Coelho. I'm a program manager in Microsoft Fabric. I'm mostly responsible for the Delta Lake experiences across Fabric, and I'm really excited to be here. Thank you for having me.
As a data engineers, we have the concept of tables. We have external tables. We have managed tables. We have the concept of views. As a person that is just starting using the tool or starting with the data engineering, it may be overwhelming and confusing. Could you help us to understand and explain the main differences between those concepts?
Sure. So I think first we should kind of look at the concepts of tables in data lakes in general. Let's lock in that concept first. Looking at the past, in regular relational database systems such as SQL Server, Postgres, or Oracle, the physical layout of the table in the disk in storage and the metadata attached to it was very tightly coupled and it was strictly controlled by the database software. When you look at data lakes, pretty much what we have is just a bunch of files lying around in cloud storage. And we have many different file types, like such as CSVs, JSONs, Parquet files, and you have very diverse folder structures containing those files. So tables in data lakes and in lake houses, it's pretty much metadata that describes what the file type looks like and how to access that file itself. It can be everywhere. So this information is then used by the processing engines such as Spark to access the data correctly, right? So that's the concept of the tables themselves. So the difference between like a managed table or unmanaged table is about location and behavior. In data lakes, so a managed table, when you use your like a create table command, usually makes the data placement more like the traditional relational database systems we talked about. So it pretty much enforces a strict location for the data and a behavior that's more like traditional database systems. The most notable example of it is when you delete that table, that data is also deleted, right? Just like a traditional database system. So it kind of tightens, it puts things together more tightly. When you talk about an unmanaged table, that's exactly what it is. It's unmanaged by the processing engine. So when you use a create external table command to define that table, and you usually point the location part of the command pointing to an external location. So that means that when you delete that table, you're only deleting the metadata. The data stays as is. That's a very usable pattern that data engineers leverage a lot because they have this massive data lakes with sensor data and a lot of data. Those things are pretty static. And you just create like a pointer to that location and you query it like a table. So that's pretty much it. I'm going to go into views now. Views is a concept that it's pretty much inherited from the traditional database systems. Uh, First is just metadata, right? You're pretty much predefining a query that's going to be saved somewhere. And instead of writing down a very complicated query all the time to be executed against your tables, you pretty much, okay, query my view. And then the view captures that definition, expands itself to the more complicated query, and then executes it. So it's like a time saver for data engineers, for Power BI analysts, for everyone. You abstract away the complex query into a single identifiable name that you use. So that's pretty much it.
That's massive. Thank you for clarification. So, in a concept like in Microsoft Fabric, we have Lakehouse, and we can operate on Lakehouse data using notebooks, and we can do a magic from the code there. We have also the SQL endpoint that is attached to Lakehouse. So we can operate with TSQL. We can create views on top of that data. Then we can add shortcut data to our Lakehouse, for example, external ADLS or Amazon S3. So, like our data is growing. As a data engineer, I have access to more data, and that's proper approach. And what is the rule of thumb here? When I should use external, when I should use manage, when I should use views in the concept of Microsoft Fabric.
Okay, so in Fabric, so by default, when you look at the way we create tables using the engines inside Fabric, all tables are created as managed, right? So when you use data flows or pipelines or the Lakehouse load to tables feature, all tables are created as Delta and they are created as managed. So we do encourage people to use managed tables primarily. It's easier to manage. It provides better platform integration. We're going to talk about a bit more about that. So if you expect just to a table behave like a table, you drop it, you rename it, you change columns, so on and so forth, focus on managed tables by default. That's what we do when you're using our Microsoft Fabric engines. Unmanaged tables are great to integration. So when you have external storage locations that you're going to map using shortcuts, you point your external table towards those locations, and they're okay. Like if it's an external shortcut, probably that data is being already managed somewhere else. So in Fabric, but I still want to query it. So then you define a table on top of it. You get all the benefits of the metadata abstraction. You can create views on top of that external location. So you bring all the benefits to that end. A cool Microsoft Fabric feature that we have is that if you define a shortcut that points to a remote Delta table, it's already Delta, and you place that into the table section of the Lakehouse, we already identified. You don't need to actually execute additional commands to define that external table. And it behaves just like that. So another point in terms of rule of thumb, like if you're integrating legacy data lakes, like full of non-Delta tables such as HT Insight, or you have external buckets on AWS or somewhere else, you create those shortcuts pointing to the file section of the Lakehouse. Then you go there and you open your Spark notebook and you type in the create external table location, and then there you get it. So on the table side of the Lakehouse, you're going to get all your tables, showing up as expected. So those are the main rules of thumb. You use manage primarily when the data is in the Microsoft Fabric Lakehouse, and you use external tables over shortcuts when things are external to you. In this demo, we will show how to approach the different object types we've talked about in Fabric. As you can see here in the Lakehouse Explorer to the left, there are two clear sections, the table section and the file section. In the table section, you should host your tables that are ready for analytics. In Fabric, we encourage you to use Delta table format, such as this yellow trip data table. Let's execute a simple Spark SQL query. You could also check the schema of a managed table in the Lakehouse Explorer itself. Fabric engines primarily place Delta tables under the table section and guarantee that they are optimized for analytics. You can identify if tables are in Delta format by the unique triangle shape in the table icon. Here is the output of the query, like some simple grouping, and here's the describe of the table. But we also support many integration scenarios. As you will notice, this yellow trip data X table is also in Delta format. The main difference here is that it is defined over a shortcut, as you will notice by the distinct icon. If you drop the table or the shortcut, there will be no impact to the data. Let's execute a query on this table. This is a powerful integration pattern to Fabric Lakehouse, to be able to create shortcuts to your existing Delta tables on remote storage accounts directly into the table section. This is great when you already have existing data pipelines generating Delta and want to avoid the data copy. But what if you have legacy Hadoop tables like Orc, Parquet, or CSV? Or even just storage accounts with simple files? This leads us to a third pattern. Let's check this shortcut here using the Lakehouse Explorer. You'll notice that the shortcut just points to a storage account with some CSV files. Now let's define an external table on top of it. This will create a table in the table section that's just pointing to the location in the file section. This is also an unmanaged table, so if you drop it, nothing happens to the files in the file section. With the table created, let's execute a query. Notice that the icon indicates that this is not a Delta table. So it might not be optimized for analytics. Yet, this is a powerful integration scenario to legacy data lakes. You'd then apply additional transformation using a pipeline or notebook schedules and then save the output into the optimized Delta table. This last part of the demo is a cool one. Now I have three tables, a managed Delta table, an unmanaged Delta table on top of a shortcut, and an unmanaged CSV table on top of a shortcut in the file section. Cool, right? I'll create a query that doesn't make much sense by joining it all and counting the rows. Let's say I use this query every day for some reason, so just save this as a view. Now, instead of running the full query every time, I just execute the view. This is a powerful usability feature, as I can share the view with other people, and if the underlying definition changes, maybe adding or other tables for example, I just change the view definition, not impacting the users or applications that use it.
Many of our customers are starting the discussion with, okay, we have 17 billion on of rows. We have 1 petabyte of data. How to process that? What is the efficient way to have, like, serve this table to, for example, Power BI users, or process this table, knowing that, yes, it may be in some different ADLS. So is there any guidance in terms of, as a customer, I have this specific number of rows or a table size, then are there any rules that I should use some approach to concept of tables, meaning that I should use views, or maybe I don't? Is there any, are there any limitations?
So I would say that, first of all, like lake houses are very flexible to scale, right? So any data size. I think one rule of thumb, if you're approaching this in terms of, okay, I want to make this data ready for analytics out of the bat, there's a lot of value in converting that data to Delta. If it's not already a Delta, just make sure that you define a strategy or an ingestion pipeline that gets your data into the Delta format. Standardizing in a single format, like it delivers a more predictable performance. I think that's the main benefit. But in the case of Delta, it provides a lot of manageability as well. So in terms of controlling the full aspects of the table itself, in terms of indexing, of ordering, it provides you additional commands to actually compact or clean the table. So there's a lot of benefit in moving towards a table format such as Delta. In terms of size, honestly, Delta can deal with it all. Like 50 megabytes, a petabyte. That's I think that's one of the strengths of that table format in particular, is that it can deal with tables at any size. Having it in Delta in Microsoft Fabric is Power BI, T-SQL endpoints, they're now all optimized to take advantage of the Delta format. So it's kind of, it fits it all in terms of getting data ready for analytics.
Yeah, and that's the unique value that the better together story is about the optimization. Yeah,
Yeah.
that's all we have for today. Daniel, thank you so much for being here and sharing all the tips, all the rules and guidance. Thank you all for watching. And remember, if you like the video, please hit the like button, subscribe the channel, and see you in the next episode when Daniel will talk more about the unique feature load to tables. See you next time.